and welcome to the video. This is one video in a series of 4 which aims to show students exactly what a grade 9 question looks like in GCSE Maths. There is actually no such thing as a grade 9 topic, as some topics can be tested at grade 5, but then that same topic can also be tested at grade 9. It is actually based on how complex and how challenging a question is. That is what qualifies a question as a true grade 9 question. The simplest way to identify these questions is to look at the very last question in recent GCSE Maths papers. Here are some of those questions. Let's have a go at this question, which is asking you to apply differentiation. It doesn't actually say differentiate in the question, but keywords such as displacement and acceleration are giving you a very big hint that you need to apply differentiation. This grade 9 question has been allocated 4 marks. Could you pause the video at this point and have a go at answering this question? Okay, welcome back to the video. As I mentioned before you had a go at the question, the keywords of displacement and acceleration are suggesting to you that you're going to have to differentiate. In the question, we are given a displacement, S, and we should know that if we differentiate a displacement, we will find the velocity. And if we differentiate the velocity, we would then find the acceleration. So we're going to take this bit of algebra and we are actually going to differentiate it twice. So this is my displacement that I'm given in the question, and I differentiate it to find the first differential, which is velocity. Remember how we differentiate? You bring the index number down in front, which gives me 3t, and then you reduce the index number by 1, which is why I'm left with the term 3t squared. For here, I take the index number, bring it down in front, multiply it with the -6, and then reduce the index number by 1, leaving me with -12t. My index number here would of course be 1 if nothing is visible. Multiply that by the 5, reduce the power by 1 to a 0, which means that I do not include a t with this term. And here the index number is actually 0, if we think about it as having an index number of 0. So when that multiplies with this constant, the constant is removed. So this is my first differential. But the question's asking me about acceleration. So I need to go ahead and differentiate again to find the second differential. So this time I'm going to differentiate this bit of algebra. So my second differential, which represents the acceleration, is 6t minus 12. Again, the constant is removed. The 2 gets multiplied by the 3 to give me 6t, and I reduce the index number by 1. The index number here would of course be 1. 1 times -12 is -12, and we reduce the index number again. So my second differential is 6t minus 12. The question asks me to find the value of t when the acceleration is 3 meters per second squared. So I'm going to take this bit of algebra and make it equal to 3. And then I've got myself a nice 2-step equation. I can add 12 to each side. I can divide both sides by 6, telling me that t would be 2.5 seconds. So the value of t, for which the acceleration of p is 3, is 2.5 seconds. Very well done if you would have picked up all 4 marks on that grade 9 question. Here we have a challenging 6-mark question which looks at coordinate geometry leading into simultaneous equations and then also solving quadratic equations. I would start this question off by drawing a diagram or a sketch which displays this information in an image, in a diagram. Could you pause the video at this point and have a go at answering this challenging grade 9 question? Okay, welcome back to the video. Let's have a look at how I have approached this question. Okay, so the first thing I've done is I've took the information that the question has given me and I have added it to a diagram. So I know the coordinates of J, I know the coordinates of K and H. I'm also told I'm dealing with an isosceles triangle. And then I'm also told M is the midpoint of JK and the gradient of HM is 2. So even though on my image, the dotted line does not really show the slope that it should, that will not impact the question that I'm going to have a go at. We do know that the gradient's 2, and I've just drawn this triangle in a straightforward fashion to show that it's an isosceles triangle. That doesn't take away from the fact that this dotted line here has a gradient of 2. So what I'm going to do now is I'm going to try and produce 2 equations which I can use as simultaneous equations. So when I'm thinking of coordinate geometry, there's a few things I can do. There's a few ways I can approach the question. I'm going to start by working out or using the fact that I know that JK is root 80. So I know that the length of this line is root 80. And I also know that this equation, using the coordinates x1, x2, y1, and y2, will give me the length of that line. So I've went ahead and substituted in the coordinates of J and K into this formula, which is essentially Pythagoras finding the distance between 2 points. So you can see here, I've taken my second x coordinate and subtracted my first x coordinate. Then I've taken my second y coordinate and subtracted my first y coordinate. And we know that all equals root 80. If I take the square of both sides to remove the square root signs, I'm left with this equation. At the minute, I'm just going to leave it as it is. Then I'm going to work on finding another equation, which I can then substitute in to equation 1. Other things I know about coordinate geometry. I can work out the coordinates of a midpoint. So I can work out the coordinates of M by adding my x coordinates together and dividing by 2, then adding my y coordinates together and dividing by 2. So that's exactly what I've done here using my coordinates of J and K. So I now know the coordinates of M. I can also now work out another equation because I'm told that the gradient of this dotted line between M and H, I'm told that the gradient here is 2, and I now know the coordinates of H and the coordinates of M. So if I substitute them into the formula to find gradient, y2 minus y1 over x2 minus x1, change in y divided by change in x. And that's exactly what I've done here. The change in the y coordinates over the change in the x coordinates. What I've wrote here is just another way of presenting this, and that's the same here, another way of presenting this. And we know that equals 2 because the question tells me the gradient of HM is 2. From this point here, I can take everything from the denominator and multiply it on the other side. So everything on both sides is being multiplied by what's on the denominator here. Once I'm at this stage here, I can simplify my algebra together. I can bring my algebra together, start collecting terms. I've expanded some brackets at this point, and then I've collected all my terms to produce this, but I'm left with a half k, so I've multiplied everything by 2. So now I've represented k in terms of j. K equals 2j plus 15. That is going to be my second equation. So I have equation 1 up here and equation 2 here. So now I know k is also equal to 2j plus 15. I can substitute that into equation 1, so I'm just left with an equation with one variable, with j, and that's what I've done here. I've substituted equation 2 into equation 1, then I've went ahead, simplified, then I've expanded those brackets that are squared, and then I've brought everything to the same side, and I'm left with a quadratic equation. 5j squared minus 12j minus 44 equaling 0. At this point, I've put my values of a equals 5, b equals minus 12, and c equals minus 44 into the quadratic formula. And then the two solutions I get from the quadratic formula is j equals minus 2 or j equals 6. But I am told in the original question that j is less than 0, which is why I've ignored the solution that is a 6. So I'm dealing with j equaling minus 2. That is one of my solutions. Then I'm going to substitute that back into my easiest equation, which was equation 2. To find the value of k. So my final answer, j equals minus 2 and k equals 11. Very well done if you would have achieved all 6 marks on that very difficult question. Thank you for watching, and remember, practicing past paper questions is easily the best way to be successful in GCSE Maths.